Welcome back everyone to another video. This is a very exciting one and I've been looking forward to it for quite a while. Before I start, big shout out to SolidRun and John Nettleton from SolidRun to arranging this, donating it to me for development purposes and just to show you guys what this is about. So this is the SolidRun HoneyComb. It's an ARM workstation, a proper ARM desktop workstation. What all of that means I'll tell you in a bit, but let me just take it out of the bag to show you guys. It's an amazing piece of kit. There you go. So this is, believe it or not an x86 PC motherboard. This is genuinely an ARM workstation motherboard. So the sock itself beneath the CPU cooler, and I'll not really take it out right now. I have a planned upgrade in my mind, but I don't know how all of that will pan out. But for the time being, the sock beneath the cooler is the LX2160A from NXP, and that's 16-core Cortex A72 at 2 GHz. But that's not even why it's important. Why it's important is because it's more in a desktop form factor. You can add your own memory. It also supports XMP memory, and in fact that's what we'll be adding today. So I have a kit of 32 gig HyperX Impact, and these are XMP SODIMM DDR4 memories, and these are what will be going on the HoneyComb, and they will be clocked at 3200 megahertz or thereabouts. So yeah, right, but is that it? No, it's not it. The thing is, this thing's ARM embedded ES systems ready or embedded server ready for the time being, and it should at some point end up being promoted to embedded server, just straight up server ready, we hope. And if not, ES is good enough. What it means, as you'd have seen with my Seattle videos, my Seattle ARM workstation, which was the old AMD based SoC, everything just works. You plug in the ISO file on a USB stick, or even plug in via a CD drive. We'll try that out, and it should just pick up the ISO and boot it as a desktop system. Everything should act as a desktop, an x86 desktop system, but on the ARM hardware. You can add your own graphics card here. That's a PCI X4 slot for high bandwidth M.2 SSDs. So those should work as well, although I'm not going to use that. I'm going to use that for separate purpose, but we'll get into that later on. And yeah, it also has 40 gigabit of Ethernet apart from the 1 gig here. So these are 4 SFP ports, SFP plus ports. For those of you who don't know, so there are 4 ports, each are 10 gigabit each. For those who don't know what SFP plus is, it's a type of connector. You can adapt that for either Ethernet or RJ45 or optical or anything else in between, I guess. It has 2 USB 2 ports here, 4 onboard SATA ports, a console UART out, so you don't have to fiddle with UART cables. A management console with onboard USB 3 header, fan headers that are controlled, USB 2 header and front panel header, and everything else is over PCIe for the most part. Alright, so as you can tell, I'm kind of rushing it a bit. I'll explain the hardware later. Again, it has an RTC clock. Which ARM board do you see that has? Well, alright, there are a few there, but not the way it exposes RTC through a CPI, so you can like literally just like the system recognizes RTC. Anyways, I'm rushing out a bit because I'm super excited to build this, and you actually have to build it as a PC the same way I did with the old Seattle. The Seattle sadly was not as system ready as this board is. Its firmware is extremely great. The other fun part, you see an SD card slot, that's not for SD card use. What we're using it currently for is UEFI firmware. So you just put your firmware in your SD card, and like if you bork the firmware somehow, you can just reflash the SD card slot. So you don't have to fiddle with SPI, you don't have to fiddle with a bunch of other things. You can just have it on your SD card slot. So that's fun. Let's build this. I'm actually really excited. So excited that I'm not even doing a good job of explaining everything here, but we'll get to that. Yeah, let's just build it. I'll do a detailed video on this board later. But I really just want it up and running because there's some cool stuff I need to show you guys. So to build it first, we need to add the memory. As far as I'm concerned, it's just you just slot things in. So I have my HyperX here, HyperX Impact, and these are XMP units. So you just take these apart to get the memory out. I should not be rushing this, but I am because I'm excited. Which way is it? Yeah, that's the one thing I just kind of don't like about DDR4 is that its notch placement is not like super off to one side. If you have a quick look, you might get confused where the notch is, but it's not like super offset, which it should be, but it's not. So whatever. All right, slot that in. I think that's properly in, and just press it down and it clips. So that's it, one memory installed. And the second one, oh, I got a nice HyperX sticker. I'll add that to the motherboard later. Sorry, to the main board. All right, so the second memory stick goes in there. Come on, is it taking a bit more force than it's in, and I can press that down as well. So yeah, both the memory sticks are in. So suddenly this has 64 gigs of memory on it, which is much more than my last work laptop, which was the Intel Xeon one that I might have talked about on this channel. So yeah, that's exciting. And and for the M.2, I want to expand it to PCI. At some point I might consider adding an M.2 SSD, but for my purposes SATA SSDs are fine. I don't have to have super high read-write speeds, so I am just going to add a M.2 to, it's not technically USB, I know it says USB 3, but it just breaks out PCI over USB 3. And again, if you've been following my channel, you would have seen these gizmos where USB 3 is just like gets broken out to, I don't know if there's an intentional sticker on there or if it's supposed to be like that. Looks like a sticker, but we'll see. So take this out and just, I don't know if this is supposed to be peeled, but it looks like it is. And then plug this in. I just posted on Twitter that I have received this board, so of course everything just, is it not touching properly? Oh, are these clips too high? Yeah, yep. It's a bit of an operation. So this thing way too high. Need to clip all of them. Now it should be good. See, I've clipped all of those. So I'll just, now if I just plug it in, kind of crunchy. Yep, now it's fine. So that's, I just get another PCI Express and then I can add an extension later. I'm not sure if I'm going to add an extension now, if I'm going to add one like externally. So like there's the wire goes out of the box, so I can have a external access to PCI. But yeah, this is just going to be X1. Although the M.2 slot does expose X4, the USB 3 port doesn't have enough wires to do X4, so it just does X1, and that's fine for us. So the board is ready to be put in. I have already prepared the desktop again as the case, the PC case. Again, as I said, I've been preparing it for a while. I've been looking forward to this, so yes, I did some pre-prep. Let's move this aside for now and bring in the PC case and see what that looks like. All right, so I have the system here, the desktop case, and just taking out the screws from the front tempered glass, and that's why the ring light is reflecting all over it. Otherwise, it's pretty black. Those out and the tempered glass off. That you guys should see the actual case. Right, so this entire bulge is for all the I/O. So I'm not entirely sure if I'll do all the cables around the back, because stuff like this, like I've always found it super hard to route the 24 pin. There's just not enough space. There's barely space for my finger to fit back there. Like I can't, like I have to jam it in. And like, look at this, how thick is 24 pin connector compared to my finger. It's much thicker. There's no way that this is going to jam in there. So when you end up closing the case from the back side, it always has issues. And some people route it over here, so there seems to be enough space, but then you have to bring some part of it out from here and then into the board. So I don't know if I should be routing through that. So I'll do a solid and not give a rat's ass about cable management right now. So all the wires can come out. So I have already have the SSD here. This is one of the SSDs that's going to go in a case or something there. And I'll buy some more later. I know it's kind of flipping around the reel. Is not sure what to make of that, but that's how it will fit. Then that's how it will fit. I don't see another place to fit SSDs. Maybe at the back, but then I'll have to open all of that stuff. So anyways, not caring about that as well. This is the rear fan. We'll just let it be. And then I have a front fan, of course, that I just bought to have enough airflow. I'll show the GPU later, but for the time being, this is what our board looks like. And yeah, let's go ahead, fix our honeycomb to this, and all of that fits there with ample space to spare. Amazing. It's much smaller. It's like I've had the same reaction with a Raspberry Pi when I first saw it. I wasn't ready for how small it was. Same with this. Like, for some reason, when someone says that it's a desktop form factor, and even if you know what the mini IT Expect means, it's always a surprise to see how small these things are. Alright, so the board is in. Next up, the GPU. Now this is a fun one because I have two. I have the one that I know works because this is the exact same one I used for my last video, which was flashing Arm 64 UEFI driver on the actual firmware of this GPU, so it always boots on Arm hardware. Now because I just have one of them, I don't really want to use this. Also, it's kind of old, so it's an R7250. from ATI, of course, Radeon. And I don't really want to use this because again, this is the only card I have that has that firmware flashed. So I'll pick another one and I'll tell you what the problem is. So this is a RX 550. The problem with this is it's a Polaris, it's a Lexa based product. So it says RX 560A right there, but the packaging says RX 550. It's kind of in the middle. No one really knows. The PCI ID, I couldn't match it with anything. The only thing Tech Power Up comes with is some Lexa based cards. So Polaris and then sub Polaris is like Lexa, which is like this half baked Polaris shit. I want to use this card because it's fairly powerful, even if it's like not super powerful, but also it has a display port and an HDMI and a DVR, so I can technically have 3 monitors all over HDMI connected to it. So yeah, I'll try and put that in. If the firmware, because this again, as I said, it's a proper desktop grade ARM hardware. The UEFI firmware has all the UEFI boundaries required. So if those work fine and this GPU works on the UEFI menu, I'll keep this. Otherwise, I'll have to switch over to the older one, to the R7. So that's what my decision is going to be based upon, if the UEFI displays something. So the board is in. I'll put in the graphic card now, and off we go, I guess. Now for the only power connector it currently requires a 24 pin power cable. Of course the hard drive would require the others, but for the time being I can see the notch right there, and one sorting thread for me. There you go. That's a nice fit. That's a really nice quality connector, because usually a lot of motherboards that I've bought, you really have to jam it in to get it to click, but this one just clicked like that. Right, so the rat's nest we have here, of course everything needs to be cleaned up a bit, but at this point it's actually ready to power on. And before I connect the SSDs, before I connect the storage, I want a proper boot test. So I'll not connect that first. I'll actually go ahead, try it booting, try it to boot first, and then I'll, because right, so I tried to boot. If there are any changes required, I'll tell you on camera. If not, then what you should see next is just mem test running, and I leave some clues in there of what's to come next. But so that's it. Thank you so much for watching, and I'll see you later where we further build this system into a working Linux machine. Thank you so much. Bye. Alright, so a small update. I tried it, and this particular GPU gave extremely pink output, which is not supposed to happen. And for that reason, I'm taking it out. Again, as I said, the UEFI support for this GPU is very weird and unclear as to even if the ARM GOP driver, like the ARM UEFI display driver, so not ARM, AMD, what the hell I'm saying, AMD UEFI display driver works with this card, or is just trying to work with this card, because that seems to be the issue, is that it's just trying to make it work. So I in fact have the R7250 that I'll plug in for the time being, which only gives me 2 display out, which is fine, I guess, but not a whole lot of graphics horsepower. So the graphics situation right now is weird. We aren't getting any new graphic card because of the shortage. The ones that are available are grossly overpriced to the point that makes me sick. So yeah, my plan was to buy a new, like the RX 6000 series for my desktop, for my main workstation, and then have the RX 580 in here, but that doesn't seem to, you know, help out in this scenario, because everything's expensive and unavailable, and you know, that's why I'm surprised I was able to get this. There were hiccups, but SolidRun and others made it clear that this reaches, so kudos to them. Right, power it on and seeing it, you know, this time I'm pretty sure it'll work. I'll add the cam link. Alright, I have directly written memtest to a USB stick. Now I'm expecting it to work. There we go, it's working now. So okay, the mouse is not working, but that's fine. It should just straight up go into memory test and start testing the memory. There you go. So yeah, the limitation on mem test for ARM is that it's okay, like it doesn't recognize all the CPU, so you can't hammer everything at once. You can't have like 16 CPU doing parallel tests, and that kind of, you know, slows everything down. But for the time being, I'll let this run and also let everything record, so you guys see a fast forwarded version of it. But yeah, it should be fun.